Welcome back. We're going to continue our factoring unit. Today we're going to factor a difference of two squares. But first, we're going to review. So let's look at our warm-up. Notice we have a binomial times a binomial. Remember, when you have a binomial times a binomial, that's when we use FOIL. First, outer, inner, last. FOIL is the distributive property, so don't be confused about the two. So my first terms will be x times x. When you multiply with the same base, add your exponents. Outer will be x times a negative 4. That's negative 4x. Then inner, 4 times x is positive 4x. And then last is positive 4 times negative 4, which is negative 16. Your two middle terms are like terms, so since they are x to the first and x to the first, add those together, but only add the coefficients. Negative 4 plus positive 4 is 0, so those two cancel out. And what you're left with is x squared minus 16. So pause the video for a moment and do the second and third one, and then mash play again, and we'll make sure you did it right. All right, welcome back. Let's distribute here. 5 times 5 is 25. When you multiply with the same base, add your exponents. 5m times negative 1 is negative 5m. 1 times 5m is positive 5m. And then 1 times negative 1 is negative 1. Again, you'll see that your middle terms are like terms, so add those together. Negative 5m plus 5m, that's 0. So if we have 0 m's, we don't write them down. And we're left with 25m squared minus 1. Okay, let's do the same thing here. 2 times 2 is 4. When you multiply with the same base, add your exponents. 2 times negative 3 is negative 6. A times b, put those in alphabetical order. 3 times 2 is a positive 6. B times a, put those in alphabetical order. 3 times negative 3 is negative 9. B times b is b squared. Multiply with the same base, add your exponents. Middle terms are opposites again, so they're going to cancel out to 0, leaving us with 4a squared minus 9b squared. And those are our results. Did you notice on all of these the middle terms were opposites? Okay, I wonder why that was. Let's look at the original problems. X plus 4, x minus 4. Everything was the same except for the signs in the middle. We had a positive and a negative. Look here, 5m plus 1, 5m minus 1. Everything was the same except positive and negative. 2a plus 3b, 2a minus 3b. Everything was the same except for positive and negative. When everything's the same, but the middle signs are opposites like this, that's going to give you opposites in the middle with your like terms, and they're always going to cancel out to 0. So really, you're just left with your first term and your last term. Okay, what this is called is a difference. Why is it a difference? Because there's a minus sign. There will always be a minus sign. It is a difference of two squares. When we say squares, we mean perfect squares. X times x is x squared. That's a perfect square. 4 times 4 is 16, a perfect square. 5m times 5m and 1 times 1. 2a times 2a and 3b times 3b. Differences of two squares. We don't have a sum of two squares that will factor, okay? All of these will factor back to an original multiplication problem of two binomials. But if there's a plus sign in the middle, you're not going to be able to factor anything but maybe a GCF, if possible, and not all the time with that. So let's learn how to factor a difference of two squares. Make sure that you actually have a difference, okay? It cannot be a plus. And both of them need to be perfect squares, meaning you can take the square root of both terms. Use the rule, a squared minus b squared. If you think about taking the square root of each one, the square root of a squared is a, the square root of b squared is b. Make one of them minus and make one of them plus. And that's going to be your factored form. And you can always check yourself by foiling or using the distributive property, which is the same thing. So when you do these, always check for a GCF first. If you have one, factor out your GCF and then do your difference of two squares. But if you don't have a GCF, go ahead and factor your difference of two squares. Let's look at number 1. I've got a minus in the middle, so I'm in good shape. A times A is A squared, and 2 times 2 is 4. So I know that those are both squares. Now what I'm going to do is I'm going to take the square root of each one. Go ahead and write down both of your parentheses because you're going to multiply two binomials together. The square root of A squared is A. The square root of 4 is 2 because 2 times 2 is 4. Make one of them a minus and one of them a plus. And you factored. It's as easy as that. Number 3, go ahead and make your two parentheses. We're going to take the square root of each one. The square root of 81 is 9 because 9 times 9 is 81. The square root of x squared is x. Make one of them minus and one of them plus. Okay, oh my, what do you see right here? A plus. Both of these are perfect squares, yes, but this is a sum of two squares. This will not factor. Okay. Perfect square, perfect square. Let's make my two parentheses. The square root of 9 is 3. The square root of b squared is b. The square root of 100 is 10 and 10. Make one of them minus and one of them plus. Square root of 16 is 4. Square root of a squared is a. The square root of 121 is 11. Make one of them minus and one of them plus. Two parentheses again. Square root of 4, square root of h squared, square root of 25, square root of g squared. Make one of them minus and make one of them plus. So that wasn't so bad, was it? Take all of these, except for this one, of course, that's prime, and you can FOIL these out to see if you got the right answer. So if we check this one, if we do first, 2h times 2h is 4h squared. Outer, 2 times 5 is 10. H times g is gh. Then inner, negative 5 times 2 is negative 10. G times h is gh. And then negative 5 times 5 is negative 5. G times g is g squared. So 4h squared minus 5g squared are going to stay. These two are going to cancel out to 0. And you see that you got the original problem. 4h squared minus 5g squared. Let's go to the next page and see what's going on there. Okay, we have x squared, y squared minus 1. If it has an even numbered exponent, 2, 4, 6, 8, 10, it's a perfect square. To take the square root of a variable with an exponent, just take half, divide it by 2. That's where I'm getting my 1s from. So the square root of x squared y is just xy, and the square root of 1 is 1. So make one of them minus and one of them plus. Okay. This is going to be the square root of 4 is 2. The square root of c squared is c. Oh my, what is this? That's a prime number. It's not a perfect square. So this is not going to factor. It's prime. Number 17, k to the 6th minus 16. Square root of each one. Now, because this is k to the 6th, okay, just do 2 will go into 6 3 times, and so the square root of k to the 6th is k to the 3rd. The reason that I can take half is because I'm taking the square root, which is root 2. And then when you multiply with the same base, you add your exponent, so you get right back to k to the 6th. The square root of 16 is 4, so we'll have k to the 3rd minus 4, k to the 3rd plus 4. Number 19, the square root of 121 is 11. The square root of r to the 6th is r to the 3rd. The square root of 1 is 1. Make one of them minus and make one of them plus. So you might be asking yourself, Ms. Patton, you have put minus first every time. Do I always have to put the minus in the left parenthesis and the plus in the right parenthesis? No, that's just my habit. Okay, you do whatever you're comfortable with. If you want plus minus, then you do plus minus. Just make sure in the parentheses you have opposite signs. Everything else should remain the same. Now, in the second part of the lesson, it says, look for a GCF first and then factor the difference of two squares. This is something you should always do in factoring. Look for your GCF first and then finish the rest of the problem. So if you look at number 21, you'll see 2 and 72 are not perfect squares, but 2 and 72 have a GCF of 2. So I can put my 2 on the outside and divide. 2 divided by 2 is 1, which is 1n squared. Negative 72 divided by 2 is negative 36. And once I have divided, look at that. It's a difference of 2 squares. So the square root of n squared is n. The square root of 36 is 6. Make one of them minus and one of them plus. And you are finished. That's your factored form. Now when you check this, don't distribute 2 to both of these parentheses. Just distribute the 2 to one of them and then FOIL it out. Or you can FOIL it out and then distribute the 2 to the final answer. Okay, so always again check your GCF first and go from there. Okay, now looking at number 23, 32 and 18 have a GCF of 2. They don't share a variable, so you can't take out a variable. So we have 2 times 32 divided by 2 is 16. Negative 18 divided by 2 is negative 9. And look, a difference of 2 squares. The square root of 16 is 4. The square root of s squared is s. The square root of 9 is 3. The square root of u squared is u. Make one of them a minus and one of them a plus. And you're done. Okay, so you're going to do that on all of these. Same thing here, GCF. Same thing here, GCF. Let's look at number 29. The GCF between 36 and 9 is 9, but this time they share a variable, p to the third and p. Always pick the smallest one, y'all. So 36 divided by 9 is 4. 3 minus 1 is 2. Negative 9p divided by 9p is negative 1. And then, look at this, our difference of 2 squares. So the square root of 4 is 2. The square root of p squared is p. The square root of 1 is 1. Make one of them minus and one of them plus. And we're finished. And remember, if you're going to check it, and you always should, distribute to one parenthesis and then FOIL. Don't distribute 9p to both parentheses. All right, so looking at number 31, 16 and 100 have a GCF of 4, and then k to the third and k have a GCF of k. 16 divided by 4 is 4. 3 minus 1 is 2. Negative 100 divided by 4 is negative 25, and then your k's cancel out. And look at that beautiful difference of 2 squares. Bring your GCF down because it has to come along for the ride. The square root of 4 is 2, the square root of k squared is k, and the square root of 25 is 5. Make one of them minus and make one of them plus. And you're finished. All right, kiddos, y'all do all of the even problems and send them to me. I hope y'all have a great day.